You look here at two examples of how to use the sine rule to find out missing lengths or missing angles within a triangle. So the sine rule is something that you would generally use in a non-right angle triangle, otherwise you just use SOHCAHTOA or Pythagoras theorem. And the way that we recognise that sine rule can be used is generally we're going to have a pair of an angle and a side that are opposite each other. As long as we know the angle and the side, and we've got that pair, then normally the sine rule will be okay for us to use. So in the first example we can see we've got that pair of 25 degrees and the side opposite is 10. What I would suggest that you always do is whatever you're trying to calculate is the thing that you're trying to, the thing that you write down first of all. So in this case I'm trying to calculate the value of x this side here. The way the sine rule works is if we have a over sine a, then that's equal to b over sine b. And the letters that are being used there denote for lowercase sides, for uppercase angles, and the a's are opposite each other and the b's are opposite each other. So in this case we can say that x over sine 75 degrees, because they're opposite each other, is equal to, and because I did a side on the numerator here, I've got to make sure that I do a side on the numerator on this side as well. So it's got to be the 10 on the top, and then the angle, sine of the angle on the denominator, which is sine 25 degrees. Okay. Now I just need to rearrange this. At the moment the x is being divided by sine 75 degrees, so I need to multiply by sine 75 degrees, giving me x equals 10 over sine 25 degrees multiplied by sine 75 degrees. Stick that into my calculator and we should get 22.9. There's no units, so I'll leave that blank, but if that had said centimetres or millimetres, I'd need to make sure that I wrote that in my final answer. Make sure that you have a check on your calculator to ensure that you can get this answer as well. If we look at question 2, again it's a situation when the sine rule can be used because we've got an angle and a side opposite each other, so we've got that pair that we need. But this time around we're trying to work out a missing angle instead. So just like I did here, the first thing I'm going to write down is the x, the thing that I'm trying to calculate. And because it's an angle, this time I'm going to be writing sine x, because it's always sine of an angle for the sine rule to work, over, and the denominator is going to be the side that's opposite the angle, in this case 7, that's equal to, because I did an angle on the numerator this side, I've got to do an angle on the numerator this side as well, so sine 72 degrees over 8. To get the sine x by itself I need to multiply both sides now by 7, so sine x equals sine 72 degrees over 8 multiplied by 7. Now the last stage in the process, I could work this out on my calculator now, but the last stage is to get the x by itself, which means doing inverse sine. On the calculator that looks like a sine to the -1 symbol, and I'll do that to sine 72 degrees over 8 multiplied to 7. And if I stick that into my calculator I should get 56.3 degrees. Just one thing to note with the rounding, okay, on the lengths of sides then I'm rounding to 3 significant figures, okay, there's a decimal point in there which you can't see so well. On this one here, when it's an angle that I'm finding, I should be rounding to 1 decimal place. Now in this particular case the rounding would have been the same either way, but that's the standard that you should be using for all CIM examinations.